Welcome to the ArgMin video channel, the least valuable math videos on the internet. This is the Real Analysis video series, lecture 19, on what it means to be relatively open and some properties of continuous functions. So let's get right to it. Start off with an example. So say we had a function from the reals to the reals where f(x) is equal to 1 if x is rational and 0 if x is not rational. At no point f is continuous. So it's discontinuous everywhere or nowhere continuous. F is nowhere continuous. Why? Since f of x minus f of a will be equal to 0 if x in if x not in Q, if they're both not rational, or if they are both rational, or 1 if x in Q, a in not in Q, or alternatively and a is rational. So nowhere can you get, let's say, so it'll fail continuity no matter what you do, where you use the definition of continuity from before. So let x be a subset of A, be a subset of Rn. We say x is relatively open. In A, if there exists some U subset of Rn that is open such that x is equal to A intersect U. Okay, some examples of this are A equals 1 to infinity, and take x as a subset of that, 1 to 2. X is equal to A intersect 0, 2. So x here is open in A, but in general, it's not open. So it's open relative to A. X is not open. And to see where that is, if we just draw out, so that's 0, this is 1, we have that, that's 2. So A goes out this way, oops. And x, take green, only goes out up to there. And x is the intersection between an open set and A. Okay. X, a subset of A, is open in A if for all A in X there exists an R greater than 0 such that you can make an open ball, intersect that, and it's fully contained in X. Also, X in A is open in A, and if A is open itself, so X is equal to U intersect A, U being open. So this is the intersection of two open sets. Intersection of two open sets is open. So we can conclude that X itself is open. It's relatively open to A and it's open. Alright, now to get a bunch of characterizing properties of continuous functions, we'll list them out. Characterization theorem of continuous functions. So let A be a subset of R n and F be from A to R M a function. The following are equivalent. 1. F is continuous on A. 2. If you have a sequence of AKs contained in A and they converge to a point A in the set A, then Fak will converge to F of A. And for every open set U subset of Rm, the inverse image of U defined as X in A such that F of X is in U is open in A. 2 just comes from definition of continuity, and 3, it's not very clear, but we'll just take it for granted for now. We might prove it later. So going back to our example, F from R to R, Fx equals 1, 0, X in Q, X not in Q. So it's like an identifier or an indicator for being a rational number. We said it was discontinuous everywhere or continuous nowhere. We're gonna show that formally. So let's fix an A in Q. If you take A plus pi over n, that converges to A as n goes to infinity, but F of A plus pi over n goes to 0, which is not the same as F of A, which is equal to 1. So F is not continuous at A by property 2. Now, if we do the same for a non-rational A or an irrational A, if we take some Qn and Q, some sequence that converges to A, that sequence will just be, let's write that as a sequence. So 1, 1, 1, 1 would go to 1, which is not the same as if you pass in the value of the sequence of QNs, what it converts to as A, which is a irrational number, which would be 0. So here, F is now continuous at A's, where A is irrational now, by the same property, property 2. And a corollary, A is a subset of Rn, mapping A to Rm is 1, F is continuous at X equals A and A, and 2, if you have a sequence contained in A such that AN goes to A, then F of AN should go to F of A. So they have if and only if properties. Okay, so that's it for this lecture. We looked at a nowhere continuous function and showed and talked about relative openness, some properties of relative openness, characterization theorem of functions, of continuous functions, and this little corollary that we ended up off with. And that's it for this little lecture. Thanks. Leave your questions below and like and subscribe if you didn't hate this video. How about that? See ya.